Okay, I've done several videos using the law of sines and the law of cosines to solve oblique triangles. In this video I'm going to look at a couple of applications that utilizes the law of sines and the law of cosines. So let's look at the first one. These two sensors are spaced 685 feet apart along the approach to a small airport. When an aircraft is nearing the airport, the angle of elevation from the first sensor to the aircraft is 20 degrees, and from the second sensor to the aircraft is 9 degrees. Determine how high in feet the aircraft is at this time. Okay, so I have a diagram here. So let's say the airplane is at this point right here. And we have one sensor, say we'll call it B, over here, and then another at this point right here, C. And at this particular point then, we want to determine the height of the aircraft. So we're looking at this vertical distance right here. We're going to call that X. Okay, angle of elevation from the first sensor would be 20 degrees. So this is 20 degrees. The point further away would have a smaller angle, so that's why I know that this one then has to be 9 degrees. Right here. Now this angle right here and this angle right here have to be supplementary. So they have to add up to 180. So I know that this angle here has to be 160. Okay, writing down all the information. This angle right here then, if I look at there's right here I have a right triangle from this point to this point to this point over here where we have the right angle. That's a right triangle. And over here I have an oblique, or in this case obtuse triangle, from points A, B, and C. So I know the sum of the angles there have to be 180. So since this is 160 and this is 9, that's 169. So this angle right here has to be 11 degrees. Okay, so basically I want to find X. So I know this angle right here is 20 degrees. So I could say, using this right triangle right here, the sine of 60 degrees would be X over this. So if I knew this side right here, I could just use the right triangle. I don't know it. But I could find it using the obtuse triangle and the law of sine. So I'm going to label this side right here as Y. And now I'm just going to use the law of sines. So over here, I'm going to say, using the law of sines, y divided by the sine of the opposite angle, which would be over here. That's 9 degrees. So this would be the sine. Of 9 degrees. That should equal, okay, and I forgot one piece of information. The sensors are 680 feet apart, so this distance from B to C is 685. And that's in feet. So I could say then that y over the sine of 9 degrees using the law of sines should be equal to 685 divided by the sine of the opposite angle, which is 11 degrees. Okay, so I have the equation then from the law of sines. Y over the sine of 9 degrees is equal to 685 divided by the sine of 11. So I've done a lot of these problems in the calculator. I'm just going to go ahead and tell you what we get. You can do it on your calculator, but you take 685 divided by sine of 11, and then multiply it by sine of 9 degrees. And you should get y is equal to 561.6. Okay. Now I know this side right here for the right triangle to be 561.6. So now I can just say, to find x, which is what I want, that's the height of the aircraft, I could just say the sine of 20 degrees should equal to opposite side. Here I'm just using the definition of sine, x divided by 561.6. Okay, so that's x divided by 561.6. So to solve for x, I would simply multiply both sides by 561.6. So basically, I would have 561.6 times the sine of 20. And that comes out, using your calculator, to 192.1. And that's in feet. And that's your solution. So notice this is an example where I used an obtuse triangle and a right triangle. So using both triangles, I was able to get the information I needed in order to find the value of x, which is what was requested. Okay, so 192.1 is the answer in feet. Let's clear this. Let's go to the next one. Okay, this one states the distance from home plate to the fence in dead center at Oak Lawn Little League Field is 230 feet. How far is it from the fence in dead center to third base if the distance from base to base is 60 feet? Okay, so I haven't loaded the diagram here. So this line that I have back here, that's the fence. Okay, so this is your diamond. So this is this is home plate right here. This is first base, second base, and over here is third base. Okay, and the distance in this diamond, the distance from base to base is 60 feet. So this is 60 feet. Okay, this is 60. And the distance from home plate to dead center, that's talking about this distance right here from home plate to dead center, that would be there. So that would pass right through second base. This distance right there is 230. And that's feet. Okay, so that's a diamond, which is nothing more than a square. So the angles are 90 degrees here. That's 90 degrees, that's 90 degrees, that's 90 degrees. But this line that I drew right here through home plate and second base bisects this angle right here. So this angle right here should be 45 degrees. So what do we want? We want the distance from dead center, from the fence in dead center to third base. So basically the distance from here to here, this is third base. So let's call that x. Okay, so remember in the law of cosines, anytime you're given side angle side, that is two sides and the included angle, you can use the law of cosines. So if you're given all three sides. Well, in this case, think of it this way, we have 60 angle, and then this side is 230. So we're given side, angle, side, and we want to find this side over here, which is x. So according to the law of cosines, x squared should equal, the formula tells you, sum of the squares of the other two sides. So this will be 60 squared plus 230 clear this one, 230 squared minus twice the product of the two sides, so that would be 60 times 230 times the cosine of 45 degrees. Okay, this one I will use the calculator. Now let me put it over here. And remember, make sure your calculator is in degree mode. So we'll just we're solving for x squared first, so this will be 60 squared plus 230 squared minus 2 times 60 times 230 times the cosine of 45 degrees. Hit enter. Okay, so that gives us x squared. So now we want the square root of that number to get x. So I'll hit second and then square root of what? Of the previous answer. So I go second answer. And hit enter. And I get then that x is equal to 192.3. And this is feet. Okay, so drew the figure, labeled the given information, and it turns out to be side angle side, so I just applied the law of cosines and found that the distance from dead center to third base is 192.3 feet. And that concludes the video on these applications. I hope this is helpful, and if it is, please subscribe, and I'll see you in the next video.